Welcome to our CDS Academy Math Tutorial Sheet 1 for 2023, which is on sets. In the first question, let the universal set U be numbered from 1 to 10. The set A has got elements 1, 3, 6, 8, 10, and B 2, 4, 5, 6, 8, and C 1, 4, 6, and 10. Find the following sets. The first one we want to find is A intersection B complement with another complement outside. So for us to be able to work out this question, first we need to distribute the complement which is outside to the inside. And so what we are going to have is when we distribute A complement, by De Morgan's law the sign on the middle changes into union, and then we're going to have B complement complement. Now two complements on B will cancel, so just remain with B. So firstly I need to find A complement. So I'm going to look at the set A. I'm going to be cancelling what is in the set A in the universal set. In the set A we have got 1, so I'm going to cancel 1 from the universal set. In the set A we have got a 3, I'll cancel 3. We have got a 6, we've got 8, and we have got 10. So these elements which have remained in the universal set which are not in A, that is A complement. So that is 2, 4, 5, 7, 9. And this is what we are saying union B. Now the set B is 2, 4, 5, 6, and 8. So union is simply combining. So we're just going to combine these two sets. In both sets we have got 2. Now we can't write the same element twice. In both sets we have got 4, we have got 5. In B we have got 6. In A complement we have got 7. In B we have got 8. In A complement we've got 9. So this is it. This is A complement union B. So also we get to work out the second one. Alright, so that is A complement union B with a complement. So also for this one we need to distribute the complement. So if we get to distribute, we're going to have A complement complement, which is simply A. The sign changes on the middle to intersection, and then the B is going to gain a complement. So I'm going to write the set A, which is 1, 3, 6, 8, and 10. And then intersection, we are now going to write the set B complement. So I'm going to go in the universal set. What is in B I'll be cancelling. So in B we can see a 2, can see a 4, a 5, a 6, and 8. So cancel those. What has remained is 1, 3, 7, 9, and 10. So this is B complement. Now intersection, we want to see what is common between these two sets. In both sets we have got 1, we have got a 3, we have got 10. So this is going to be A intersection B complement, which is A complement union B, A complement outside. The next one we want to find A intersect B union C. So firstly let's find A intersect B. So we want to find what is in A and in B. That's A intersect B. So we can see that 1 is not common in both sets, 2 is not common, 3 is not common, 4 is not common, 5 is not common, but we can see 6 is common in both sets and 8 is common in both sets. So it is just 6 and 8, which is A intersection B. And then union the set C. So the set C is 1, 4, 6, and 10. So union is simply combining. So if we combine both sets, the smallest is 1, the next number we have is 4, and then we have got 6 in both. We'll just write it once. We've got 8 and then 10. So this is it for this one. We can also get to look at now the last one on this part, which is the A union B intersection C. Now A union B means combine everything in A and in B. In A we have got 1, in B we have got 2, In A we have got 3, in B we have got 4, in B also we have got 5, in both we have got 6, in both we have got 8, and then in A we have got 10. So this is union. You combine just, and then intersect the set C, which is 1, 4, 6, 10. So this is going to give us, we have got first 1, which is appearing in both sets. We have got 4 appearing in both sets, 6 appearing in both, and 10. So here it was just supposed to be 1 comma there. So this is A union B intersect C. Let's consider this one. Shade in the Venn diagrams below the following sets. The first one we want to shade is A intersection B union C. So the first one that I'm going to shade is B union C. B union C means everything in B and in C. So this is the set C, and then union the set B. There is a set B. So we want where this B union C is intersecting with the set A, or where it is meeting with the set A. So we can see it is meeting with the set A in which region? So it's this region which is here. Also this region which is here. So therefore the final answer should just be the portion that I've shaded in red. So the answer for this one is just going to be here, where the union is intersecting with the set A. So that is going to be the answer. What of the same set now shading it here? How can we get to shade it? So again, I'll shade B union C. B union C means shade everything in B and everything in C. So let me start by shading everything in C, which is there. And then I'll shade also everything in B, which is also there. And now we want where these red lines are meeting with the set A. So we can see these red lines are meeting with the set A here. So B union C is meeting with the set A at that point. So which I can write as a final answer, just shade that region, which is just A intersection B. So just this region. This is where the union of B and C is intersecting with A. Alright, let's consider B minus C. Now B minus C, we know it also means B intersection C complement. So we want what is in B but outside C. That's the meaning. B intersection C complement. Should be in B but not in C. So it is this region. So that is the B intersection C. It is in B but not in the set C. Forget about the set A because it's not here. So you just look at B and also C. What of the other set? How can we shade B intersection C complement? We want to shade what is in B but not in C. So it's going to be this region. You can see that that part is in B but it's not in C. So that is going to be the B intersection C complement. Alright, we can go to part 3. We want to shade C minus A intersect B. This I can also simplify to say C, the minus I chose into intersection. So the second part, which is the A intersect B, is going to carry a complement. So that is C intersect A intersect B complement. Now the first thing that I'm going to do is first shade A intersect B. So A intersection B is this middle part. Now we want complement. So what is outside? That part I've shaded. But it should be in C, meaning it should be in C. That's the intersection. So what is outside what I've shaded? That is the complement of A intersection B, but should be in C. Okay, so we can see that if we want to get that, this is the set C. So just excluding that part that we've shaded in white. So this is going to be the answer, just the red portion. What of in the other set? Let's try to shade A intersect B where A and B are meeting. So intersection B is meeting here, including the portion that is in C. We are only interested in A intersection B. Now we want what is outside what I've shaded in red, but it should be in C. Outside what I've shaded in red, but it should be in C. So we are going to say that this is the region I've shaded in green. So this is going to be the answer for this one. And then we are on part 4. We want to shade A. This was actually just a mistake. Supposed to be A intersection B intersection C complement with a complement outside. So it's supposed to be an intersection on the middle here. So first I'm going to distribute this complement to the inside. So we're going to have A intersect, the B carries a complement, the sign changes into union, C complement gains another complement, so it just becomes C. Now firstly I'm going to shade B complement union C. Now B complement union C is different from B complement intersection C. B complement union C, let me shade B complement first. Everything outside B, that's our B complement. Now together with C, so also shade the set C. So I also shade the sets including that portion that is in what? That is in B. And then we want what I've shaded, where does it intersect with the set A? Where does it meet with the set A? So you can see it is meeting in this region with the set A. Those lines are meeting with the set A even here. Just excluding this part. That's the only part which is an exception. So what will be the answer for this question? The answer for this question would be the whole of this. So that is what you're supposed to shade. Now what of in the other set? How can we shade the same A intersect B complement union C? So first I'm going to shade B complement union C. B complement means everything outside B, so we are shading outside. Union C means together with C, so I'm also going to shade the set C. Now we want where these shaded lines are meeting with the set A, where they're intersecting with the set A. So you can see that here they are meeting with the set A, even here, okay, we are meeting with the set A. So what is going to be the final answer for this shading? So it's going to be this one. You shade this portion and also shade this portion. So this is going to be the final answer for this question. All right, let's work out now the last part on this question. A complement intersect B minus C. So I can also say this is A complement intersect B intersect C complement. That's the B minus C. So firstly, I'm going to work out this. B intersect C complement. So we want what is in B but outside C. So this is different from union. Union means shade what is outside C and also what is in B. But intersect means shade what is in B but not in C. So that's the B intersect C complement. So I'll shade what is in B but not in C. So this is the region. We saw that is what we shaded on B minus C. Now we want where it intersects with the portion that is outside A. So this I've shaded is B intersection C. Now I want to shade with where it intersects with the portion outside A. So the portion outside A, they meet here. The shaded region where it intersects with the portion outside A, it is here. So therefore the final answer for this question, you just get to shade this portion. So that is it. Alright, what of in the other set? You also want to shade the same. A complement intersect B minus C. Now the first thing that I'm going to do is shade B minus C. We know B minus C is B intersect C complement. What is in B but outside C? It is this region. This is the one we shaded. Now we want where this portion is meeting with the part that is outside A. So it shouldn't be in A, but what is outside A? So the part that is outside A but meeting with the red lines is this portion. So this is what we're supposed to shade, the one just in white. So we'll not include the one, this portion, because it is in A. So we want what is outside A. So this is it for this question. All right, another one here. Express the following sets in the simplest form. First one we have is P complement union Q minus P, the complement outside. For this one, I'm going to change this minus to intersection. So we're going to have P complement union Q, the minus becomes intersect P complement. Then we're going to have a complement outside. So I'll distribute this complement to P and also to this portion. So if it goes to P, you're going to have to P complement, you're only going to have P because there are going to be two complements on the P. And then the sign here is going to change into intersection. And then also distribute this complement goes on this part. Then that becomes Q intersect P complement and then a complement outside. Now I'm going to distribute this complement to the inside. So we're going to have P intersect. We are going to have Q complement. The sign changes into union. P will again another complement, so there will be two and then they are going to cancel. So this is supposed to be the answer. I actually changed this one. This one is supposed to be R, so I'm supposed to be carrying it with an R like that. Alright, so this is supposed to be answer because we have got three different letters. But in a case, the way I started with it, just a P if there was no R. So you can't leave this as your final answer. You shouldn't see the same letter twice when you are simplifying sets. So meaning that we should be able to simplify this one further. So in a case where you don't know what to do, well, at this point I can first use the distributive law. The P intersect, I'll distribute to this, so it will become P intersect Q. And then we'll get the sign which is on the middle, that's the union. The same P intersect will distribute to this, it will become P intersect P. So this is going to be P intersect Q and then union. Every time you intersect or take the union of the same set, it will be that same set. So P intersection Q and P, we want where we find the union when we join them. Again, we shouldn't see the same letter twice. So P intersection Q is a smaller set as compared to P. Every time you are taking the union of a smaller set and the bigger set, the answer will always be a bigger set. So P is a bigger set, so that's going to be the answer. But if you are taking the intersection of a smaller set and a bigger set, the answer will always be a smaller set. So if it was intersection, the answer would be P intersection Q. Why am I saying that P intersection Q is a smaller set? If you look at this, if you have got this as P, this as Q, P intersection Q is just this region. You can see that this region which I've shaded is actually inside P. So if you take the union, we get that part I've shaded, union the set P. Union the set P. Union means combine. You will see the answer will just be the same set P. So that is how you get to work it out. Let's work out part B. We want to work out X union Y intersection X. Now, just as we are from saying on the previous question, when you are taking the union of a smaller set and a bigger set, the answer will always be a bigger set. So X is bigger than Y intersection X. So the answer is going to be X because we are taking the union of those two sets. Part 3, we want to work out M intersection N union N complement intersection M. So since I've started with M here, but here I've got N, we know that by the law of commutativity, I can as well bring this M this side and then the N complement this side. It will still be the same thing. So I can do that. This is going to be M intersection N union. We are going to have M intersection N complement. Now, from here to simplify, I'll look at what is common in both sets. We have got M, we have got M, and then the sign also on the middle should be the same, right? So Here we have got intersect M intersect. So I'm going to factorize out M intersect. So what is going to remain in this set is N. Then you get the sign on the middle, union. What remain in this set is N complement. So this will give us M intersect. Now N union N complement. When you get the union of a set and its complement, you are going to get the universal set. So if you have got, this is your set M or your set N. M itself is this one. M complement is what is outside. So if you combine these, you see you are getting the of the universal set. And every time you take the intersection of a set with the universal set, it will be that same set, right? So the answer is going to be M. This is it for this question. So let's get to look at the next one, which is D. We want to work out A minus B. So I can change this into A. This minus we are seeing is going to become an intersection, and whatsoever is inside, since we have changed the intersection, a complement is going to come to the outside of the whole of this portion. And then what is inside is A minus B also. So I also change this into A intersect. The portion which is at the end will carry also a complement. And then I'll distribute this complement to the inside. So we're going to have A intersection A complement, the sign chosen into union B, because two complements on B, they'll cancel out. Now A is a smaller set as compared to A complement union B. Okay, so actually for this one, let me not even do that. Firstly, let me distribute. So the A intersect, I'll distribute to this. So we're going to have A intersect A complement, and then we're going to get the sign on the middle, which is the union, and then the A intersect to distribute to that, we are going to get A intersect B. Now A intersect A complement is an empty set. You don't have the intersection of something that is inside the set and outside the same set. So these two can't meet. The inside and the outside of a set can't meet. Just like what is inside our bodies can't be outside our bodies. Okay, so that will be union A intersect B. Now an empty set is a very small set. Every time you intersect an empty set, or you take the union of an empty set with any other set, it will be that same set. So the answer is A intersection B. But if you intersect an empty set with any other set, the answer will always be an empty set, right? So let's get to look at part E. We want to work out A union B minus C. We simplify. So we have got all different letters. We can't simplify further than this for this question. We can only express it in that another form, and it will be A union B intersection C complement. You can't simplify it further than this because you have got three different letters, right? Or we can try to even see how it's going to look in a Venn diagram. So if you have got, this is your A, this is your B, then this is your C. B intersect C. You want what is in B but not in C. What is in B but not in C? This is the region. Union A. So together with the set A, together with set A, meaning I'll also shade everything in the set A. So this is the region we are talking about. And we can't give it any simpler explanation than what we already have, or any simpler expression than what we already have. Alright, we now want to work out F, which is A intersection B complement union A minus B, the complement outside. I'm first going to change this minus into a intersection. So we're going to have A intersect B complement union. We are going to have A intersect B complement, and then another complement outside. So I'll distribute this complement to this, and to this. So if I distribute, we are going to have A intersect B. There are going to be two complements, this one and this one. So they will cancel out. And then the sign on the middle is going to change. So we're going to have intersect. And then we are going to bring also this complement here. It becomes A intersection B complement with a complement outside. So we have said the two complements are going to cancel out, intersect. I'll distribute this uh, complement which is outside here to the inside. So what are we going to have? We are going to have A complement the sign changes into union B. Now for such a one, I'm not going to factorize out, because even if I wanted, this is B intersect, this is B union, so I can't factorize out this well. So what I'm going to do is, if I want to simplify it better, I can even use a Venn diagram to do that, because I don't want to see the same letter twice. Then that means I've not simplified. So this is the set A, there is a set B. So I want to work out A intersect B. This is the one here in green. And then A complement, I'm going to draw also another set. This is A intersect B. Okay. Now I want A complement union B. Everything which is outside A, everything. Together with the set B, meaning also shade the set B, including that set portion that is in A. So this is it. Now this is A complement union B. Now what do you think is common between these two sets? That's intersection. You want where they are common. So you can see that the middle is shaded. Also here the middle is shaded, meaning that the answer, the intersection of these two sets, is simply A intersect B. So this is where we are saying, when you have got the intersection of a smaller set and a bigger set, the answer will always be a smaller set. A complement union B is much bigger than A intersection B. We can work out the last question on this part, which is B complement intersection A union B. If I want, I'll just go direct into a Venn diagram and be able to simplify this. Or I can distribute the B complement intersect to the A, so that to give us B complement intersection A. And then I'm going to get the union here. And then I'll distribute the B complement intersect to the B to give us B complement intersect B. So this is B complement intersect A union B complement intersect B. Every time a set intersects with its complement, the answer is an empty set. They don't intersect. So what are we going to get from here? Every time you get the union of a set with an empty set, it is that same set. So this is going to be the answer for this one. Right. Let's consider question number 7. If A and B are disjoint sets of the universal set U, simplify each of the following. Now they have told us these are disjoint sets. Disjoint sets are sets without an intersection. So I can just show this. We have got a certain universal set U, and then you have got some two sets which are not meeting, A and B. Right. So if we get to look at the first part, A intersect B, since these are disjoint sets don't have an intersection. So A intersection B is an empty set, right? So that is the answer for that one. And then for part B, we want to work out A union B. Now when you get to combine the set A and the set B, it will simply be itself the set A and the set B. So the answer is just A union B. So if these two sets, let's say the elements in the universal sets, you don't have any other element in the universal set apart from the elements in A and in B, meaning that A union B will also be considered as the universal. So A union B will be considered as the universal set. So for example, let's say we have got A as 0 and 1, and then B has got the elements, let's say 2 and 3. And then the universal set just contains these two sets. It doesn't have any other element apart from these two. So meaning that the universal set is going to have the elements 0, 1, 2, and 3 if it doesn't have any other elements. So you see, if you are talking of the union of this set A and this set B, you are just going to get the universal set U. Okay, so that is going to be the answer. Now I've used E here, you can also use U. Now what of A complement intersection B? You want what is outside A, but it should be in B. Now, as we have said, you have got a set A which has got the elements 0 and 1, the set B which has got the elements 2 and 3, meaning that the universal set, since it doesn't have any other element, okay, we take it that it doesn't have any other element, and then the universal set is just going to have 0, 1, 2, and 3. So if you are talking about what is outside A, then obviously it's going to be in B, because the universal set doesn't have any other elements. So A complement is going to be B. Anything outside A, then it is in B. So that will be intersection B. So this is going to give you B. Every time the set intersects with itself, it will be that same set. What of A minus B? You know A minus B is A intersection B complement. So again, if you are talking about what is outside B, then it is going to be in A. And if an element is in A, intersection A, it will just be A. Like if you intersect the same set, you just get that same set. Then the next one, we want to work out B complement union A complement. We know from the De Morgan's law, this is the same as B intersection A with a complement outside. And we know that these two are disjoint sets, they don't have an intersection. So that would be B intersection A is an empty set, but there's a complement outside. And the complement of an empty set is a universal set. Complement of the universal set is an empty set. So this is going to be the answer. And then the last one, want to work out A union B minus B, which we can also say is A union B intersection B complement. I can as well bring this in front, so we're going to have B complement intersect A union B. So if I distribute the B intersect to the A, that is going to be B in complement intersect A. I'll get the sign inside the brackets on the middle union, and then I'll distribute the B complement to the B, that will be B complement intersection B. So B complement intersection A, and then union. B complement intersection B, we know that that's an empty set, right? And then any set union an empty set is that same set, so it is B complement intersect A. Now also show that B complement is A. If an element is not in B for such a set, which is this one, then it's going to be in A intersection A. So we see that it's going to give us A. Let's consider now the last question in this practice. Let R be the universal set and A be -1 to 6, B 0 to 4, and C has got X, which is such that X is greater than or equal to 4 and X is a real number. B subsets. Illustrate each set on the same number line, hence find each of the following. So let's first illustrate each set on the same number line. So let's say here is a number line. We have got the set A, which is from -1. Let me put -1 here, up to 6. Now we can see we are not including -1, but we are including 6. Okay, so that's the set A. And then the set B is from 0 up to 4. So let's say 0 is here and 4 is here. And we are not including any because we have used open interval brackets on both ends. And then we have got the set C. Now set C has got X, which is greater than or equal to 4. So we are starting from 4 greater than or equal to, meaning that starting from 4 including 4, and then greater than or equal to, meaning that we are going in this direction. We'll just put an arrow because it's greater than or equal to. We don't know where we're ending since the universal set hasn't been restricted also. So meaning that for C, if I want to write it in set notation, is going to be, in set intervals, is going to be 4 to infinity, like that. So this is a set C. Now the first one, we want to work out A minus C. We know that A minus C is A intersect C complement. So we want what is in A but not in C, right? So it is from this region, from -1 up to 4. 4 itself is in what? Is in A. Is in C. So we don't want it to be there. We want what is in A but not in C. Okay, so that is going to be the answer from -1 up to 4, and both are going to be open. Or we can find C complement first. C complement is going to start from here. Since all the elements this side are in C, then C complement is going to start from here going in this direction. Okay, but we have put open here because C complement, if 4 is in C, then it can't be in C complement. Now want where C complement is meeting with the set A. This is the set A down here. Where are they meeting? That's the intersection. Is here up to here. So this region. So you can see that -1 is not part of the set A. Therefore, it can't be part of the intersection. 4 is not part of the set C complement. It can't be part of the intersection. That is why we used open interval brackets. All right, let's look at the next one, which is B complement intersection C with a complement outside. So this one, I'll display the complement, then that will give us B union C complement. So B union C complement, again we are dealing still with C complement. So C complement starts from here going in this direction. Now union means get the set B together with the set C. Okay, so the set B, you can see, is actually covered in the set C complement. So the whole of set B is covered in the set C complement. And you know that the union of a smaller set and a bigger set, it will always be the bigger set. Meaning that B union C complement, which is the B complement intersection C with a complement outside, is simply, where is the set going this direction? It's -infinity. You always start with a smaller number. So -infinity, 4. Now 4 is not being included. 4 is not in B, it is not in C complement. And then -infinity shall never be included in the set. Right, so that is the answer for that one. And then the next one, when we work out C minus A intersection B. We can as well simplify that into C intersection A complement and then intersection B. So A complement, this is our set A here. So A complement, we are going to start from here, going in this direction, and then also start from here, going in this direction. Now, since -1 is not in A, meaning that -1 is going to be in A complement. So what I've put in white is A complement. Now, we want where A complement is meeting with the set C, where is it intersecting with the set C. So you can see that from just here all the way to infinity, A complement and C, they are going to intersect. So everything this side, they are going to intersect, right? Now, where is that portion I've shown, this portion, meeting with the set B? Is it meeting with the set B? You can see the set B just starts from here to here. They can't meet, all right? These two sets can't meet because there are some elements between 4 and 6 which are separating them, so they can't meet. Meaning that this one, the answer is an empty set because they are not meeting, right? And then we want to work out just A complement for part D. Now A complement, just as we have seen from part D, is just going to be, the smallest number here is -infinity. and then we come to end at -1. -1 is being included. Okay, and then we continue from 6 up to infinity, which is here. This is also a complement up to infinity, so that is a complement for this question. And then the last question on this part, we want to work out A intersect B complement. First thing I want to find is A intersect B. So A intersect B is going to be here. So the whole of this region, that is going to be A intersect B. That is where the set A and the set B are meeting. Now you can see that 0 is not in B, 0 is not in, even 4 is not in B. Meaning that 0 and 4 will not be part of the intersection. Since we are looking at their complement, meaning that 4 is going to be in the complement going in this direction, and then 0 is going to be in the complement going in this direction, meaning that A intersect B complement is going to be, this side we are going to negative infinity, we are going to positive infinity. So we're going to have negative infinity, comma 0. 0 is being included, union 4 being included up to infinity. Infinity is never included in any set. So this is how you get to work it out. Well, thank you so much. Here is where we end with this tutorial. Hope you get to subscribe to our channel to get to support us. Stay blessed.